Alright, so continuing with our atmospheric science notes, they should be part 3 or the third part and third page. So the next thing we're going to talk about is layers of the atmosphere. Okay. So we're going to start at the top, and I'm going to draw a line. So the highest layer of the atmosphere is called the exosphere. And this is the boundary of the atmosphere and outer space. Okay, and then going down, the next layer is the thermosphere. And the thermosphere is where satellites orbit, and the northern lights, like the aurora borealis, it's kind of in the thermosphere and in the next layer below. So satellites, 20. The aurora borealis is in this layer and in the layer below called the mesosphere. Okay, so we can draw our little satellite up here. Okay, so going down, draw another line separating this layer. Okay, and then we have the mesosphere. Okay, so we said the mesosphere can have some of the aurora borealis or the northern lights. This is also where meteors are. You can draw a little meteor. Okay. Going down another layer, we are entering the stratosphere. And this is where the ozone layer is. This layer is good. It protects us from the UV damage from the sun. In the stratosphere, also some planes do fly here to avoid turbulence. A lot of your commercial airlines will go up into the stratosphere so that it's not really a bumpy ride. Okay. So you have here your ozone layer. And then underneath that you have some planes that fly here, so and going down another layer. Okay. Next one is the troposphere. Okay. This is where our weather, air pollution, greenhouse gases are. A lot of other smaller planes usually fly in this area. So you're gonna have a little cloud with rain for our weather. You can have some smaller planes. You can have a tree in this one. So this is kind of our layer. And the bottom line is our ground. Okay. So you can pause and catch up on that if you need to, but we're gonna move down into what is called inversion layers. Okay. So inversion layers occur when layers of air do not mix. And one of the reasons for this is because they are different temperatures and therefore different densities. So some air is heavier than others. Okay. So this, when an inversion layer happens, it can trap in air pollution. Okay, and then underneath here, we're going to draw 2 of the many ways that this can happen. So we'll write below are 2 of the Alright. So now is where we are going to draw a picture. Actually, I'll make another mountain over here. Okay. So down here we may have some little houses and some buildings. Over here, this is our ocean. So we'll make some little houses over here along the beach area. We'll have some snow up here on the mountain. Alright, so the first type of inversion we're going to talk about is called marine inversion. So we're going to draw a line here to kind of separate our 2 different types. So this type will be, let's write it down here, marine inversion. Okay, so we know when the sun is shining down, land normally heats quicker than water. Okay, so we can kind of make that note, land heats quicker than water, because we know water has a high heat capacity and it takes a while to cool it off. Okay, and then think about when you go to the beach in the late afternoon, usually there's a cool breeze coming from the water side. So that cool air is coming in from the water. So let's draw a big arrow coming this way. Okay, so this is going to be our cool marine breeze in afternoon. Okay. And then since our area over here on the land, it's been daytime all day. So of course this area over here, the land is going to be a lot warmer than the water, because remember, land heats quicker than water. So we have a big arrow this way. Because this is the warm air from land. Okay? So the way an inversion happens is cool air is more dense. So if it's more dense, that means it's going to be heavier and naturally go towards the bottom, and warm air is going to have to go on top of it. So it kind of forms this little, as the breeze comes in, the warm air comes and pushes that the cool air from the ocean comes and pushes this warm air up. So this is called an inversion because naturally we know, if you think about it up here, the ground is a lot warmer than the atmosphere. As you go up, it gets a lot colder. So this is an inversion because it's now flipped. Now we have cool air down lower, and as we go up higher, we have warm air. So I hope that makes sense. So since this cool air is more dense, it comes to the bottom, the warm air goes up. All right, so now another type of example. Let's go ahead and write this note up here just so that it helps when you're studying to understand. So typically, the earth is warm at the surface. And gets cooler as you go up. Okay, so that's why an inversion is different here. Cool air at the bottom, warm air up higher. So another example of this is we have a little community down here in the valley. So think about if it's winter time, this little community down here is going to be cold. You know, the mountains are shading it. It's winter time. It's just typically going to be cold in this community. So during winter, mountains are shading. And it's just cool here. Okay. So we have cool air down here. So what happens if we have a warm day, the cool air is still more dense. So if a warm day comes through, then we get, we'll have a block here, warm air from warm day. Okay. So when it's been winter time, a warm day comes, and now this warm air is coming down, and it's essentially trapping this cool air in here. So this is almost acting as a lid. Okay, and normally a high pressure system, so like when the weather changes to warm, a high pressure system is normally what's keeping this warm air pushing down. Okay. So the reason that in a community like this inversion of cool air being down here and warm air being up here is bad because this community, everybody's riding in cars. Maybe this is a little factory, so we've got little smoke coming out. This traps pollution. Because the air in here is becoming stagnant. We have this warm air on top holding all of this cool air down in here, so there's no way for this pollution to come out and vent and get essentially fresh air. We're just trapping the pollution down into this community. So again, the reason these are called inversions is because typically we're warm at the ground, cooler as we go up. But in some circumstances, these are two examples. So the cool breeze coming, warm air coming on top, it's an inversion, and down in a valley where it's cool, and then we have a warm day come and pushes that cool air and keeps it down in here. Okay, and then the only way to stop this type of inversion is you have to have some kind of storm system come through to break up this little trap of air in here. So we'll put needs a storm to stop this. Okay, and that'll be it on page 3 of the atmosphere note.